Okay, calculating compound gear trains. I'm going to jump over real quick to on shape, and I'm going to show you that a compound gear train is really when you have more than one simple gear train where, like you see here in the middle, two gears share the same axle. So you'll see that these two gears in the middle are rotating together, meaning that they're locked together on one of these axles. So you can look at this entire system here as being two simple gear trains connected together. So if I'm going to calculate the total gear ratio of this gear system, the way I would do it is I would first calculate the gear ratio of this first gear to the second gear right here. Find out what that gear ratio is, and then I would multiply it times the second gear ratio of this system, which is this other little gear here, which is attached to the axle, and the fourth gear, which is the 62th gear here. Okay, so there's two simple gear systems in this compound gear system. All right, so if I go back to the activity here, you'll see that in this example I have an A, a B, a C, and a D compound gear system. B and C are sharing the same axle. So in my mind, I have to break these out into two separate simple gear trains. We have A connected to B, and we have C connected to D. Okay, remember, B and C share the same axle. All right, so they're rotating at the same speed, they have the same torque. So what I would do is I would calculate the gear ratio from A to B first. And if I know like the number of teeth on gear A, and I know the number of teeth on gear B, then I could use my gear ratio formula of N out over N in, and I could solve and find that the gear ratio for this one is 2. Now if I look at the second simple gear train, which is gear C connected to gear D, then what I can do is I can count the number of teeth, which is 24, on the large gear of D, and I got C, which is 8 teeth, and I can calculate that the gear ratio for that is 3. All right. Total gear ratio is then found by calculating the two gear ratios together, by multiplying the two gear ratios together. Okay, so if I have a total gear ratio of 2 in this first simple gear train, and then I have a total gear ratio of 3 over here, 2 times 3 gives me a total gear train of 6. All right, so that's how you solve for the total gear ratio of this entire gear set. Okay, and you can see that down here. Gear ratio from A to D is 6, and that's by using the fractions, multiplying the first gear ratio times the second gear ratio. All right, so that is compound gear trains. And if you go and you look at this, this moving, you can see that this gear is moving 1/6 the speed. All right, so that means basically that this little gear would have to rotate 6 times before this moves one rotation or one revolution. All right, so you're getting 6 times the force. Okay, that's another way of looking at it as well. All right, let's analyze the compound gear train. So we have kind of a diagram showing my little gear connected to my gear B, which has 36 teeth, and then we have C, which is connected to the axle of B, and then connected to D, which is a 60 tooth. I'm going to scroll down. I'm going to type in my data. I can look at my on shape if I'm not sure how many teeth are on. It tells me right here it's a 12-tooth drive gear. You can see here under where these teeth were inserted. So I know I've got a 12, a 12, a 36, and a 60. So I can type those numbers in here. I've got a 12 for A. I've got a 36 for my B, and I've got a 12 for my C, and I've got a 60 for my D. Now, very simply, what I can do is I can calculate, remember my formula is out divided by N when I'm looking at my teeth. Okay, so I'm going to open up my calculator. Okay, use this one so you guys can see what I'm calculating. So out over in, so my out is going to be 36, so 36 divided by my in, which is 12, gives me a gear ratio of 3. Maybe I'll type that out so you can see what I'm doing. Okay, and then my D, my D to C, so my out would be my 60-tooth, so out divided by my in, which is my 12-tooth, equals, my calculator, it's pretty simple numbers, but I'll still make sure I do it correctly, gives me 5. 5. Okay, so gear ratios as fractions, I already kind of did that up top, but I'll just kind of bring those down, just like that. Product of fractions, they're asking me to do it, so I'm going to do it. So my numerator is 36 times 60. My numerator up top, oops, forgot to look at it, 2160. And then my denominator down below is going to be 12 times 12, which should be 144. Okay, so 2160 divided by 144 gives me 15. Okay, so my final gear ratio is 15. If you notice, if I would have multiplied 3 times 5, I would have gotten 15. When I did the product of the fractions, 2160 divided by 144 also gives me 15. So it all came out to be the same. When I come down here, it says, how many times will gear A rotate compared to gear D? Okay, so again, it's asking me rotation, so that is RPMs. So what I'm going to do is I'm going to look at my formulas, which are WN, which is RPMs in over RPMs out. Okay, and I'm going to look at my gear ratio, which is 15 to 1, and I'm going to compare those. This is where you guys got to look at your formulas and you got to try to solve to compare. So if I have 15 to 1, you got to compare those and try to figure out if I have one rotation of gear 1, how many rotations am I going to get on gear D? Okay, 1/15 of a rotation because you're going to get an increase in force. All right, so use your formulas and solve for whatever that solution is. Okay, and then here where it says 7 foot-pounds of torque is applied at gear A, the formula you would use for that is torque out divided by torque in. Okay, substitute and solve. All right, so for this one, we're going to look at what is the total torque out over the torque in. So they're saying we want to know, this is hard to do on a computer when I'm typing in a linear way, but I'm going to try it. Torque out, we want to solve for the torque in is 7 foot-pounds. We're going to set that equal to our gear ratio of 15 over 1. So if I cross multiply and divide, and I apologize for it being on a straight line because I'm typing, but if you cross multiply and divide, you should be able to solve and figure out what is the output torque of this total gear ratio. using the total gear ratio of this system. All right. Um, Go ahead for number 3. Why might compound gear trains be better than 2 gears alone? You should be able to look at this and figure out the massive increase in mechanical advantage or gear ratio that you can achieve by using a compound gear train as opposed to just a single simple gear train. And then for number 4, I want you to do some maybe Googling and try to find where you would find a compound gear train, or maybe in just simple objects around the house. Okay, so again, make sure you complete this entire document, including conclusion questions, solutions, and submit it when you're complete. Thank you very much.